So find the following probabilities for z-scores. Recall that z-scores always have a mean of 0 and always have a standard deviation of 1. And we'll assume the z-score has a normal distribution. So for part A, find the probability that the z-score is more than 1.4. Well, I go to the normal CDF. I want to be more than 1.4, so that means 1.4 to 999. Mean of 0, standard deviation of 1. And I say that probability is 0.0808. If I want to find the probability that z is less than negative 0.6, I use the normal CDF. I want to be less than negative 0.6, so that means you're going from negative 999 to negative 0.6. And I get about 0.274. If you see the vertical bars, that means absolute value. So treat it without the absolute value for the moment. So normal CDF, 0.5 to 999, paste, and then times 2. When you have the absolute value, you're looking at both tails. So times 2. All right, so 0.617. All right, so going a little slower, try these again. If I want to find the probability that z is more than 1.4, graphically that means 1.4 is right here, and I want everything beyond it. So my lower bound is 1.4, my upper bound is 999. So normal CDF, 1.4 to 999, mean of 0, standard deviation of 1. It's 0.0808. If I want to find the probability that the z-score is less than negative 0.6, well, my lower bound is all the way on the far left, say negative 999. My upper bound is right here at negative 0.6. So negative 999 is the lower bound, negative 0.6 is the upper bound, 0 is the mean, 1 is the standard deviation. That comes out to be about 0.274. For part C, the absolute value is greater than 0.5. You find for one side, so 0.5 to 999, okay, and then double it. Okay. So we do is we find one side, times it by 2, we get 0.617. So my recommendation for you is to always draw the picture first. Doesn't have to be perfect, but it allows you to figure out what your lower bound and upper bounds are. So for any normal probability situation, and we'll be doing this for p-values, you always draw the label and normal curve and shade the area of interest first. So again, it doesn't have to be perfect. It's just meant to give you guidelines for the lower and upper bounds when finding the probabilities with a normal distribution. All right, one last example. Cumulative SAT scores are approximated well by a normal model where the mean is 1500, standard deviation 300. So Shannon is randomly selected SAT taker, and nothing else is known about her aptitude. What is the problem that Shannon scores at least 1630 on the SATs? So in this case, the mean is 1500, standard deviation 300. So there's the peaks at 1500. There's 1630 right there. We want everything to the right. At least means more. So the lower bound 1630. The upper bound, I'd go an extra 9, so 9999. So your calculator, second, VARS, normal CDF, 1630, 9999. You can do more if you want. Have fun. The mean is 1500 and the standard deviation 300. Paste. And I see the probability is about 0.332. Okay. So the probability that Shannon scores at least 1630, if it's a randomly selected student, is about 33%. Edward earned 1400 on his SAT. What is his percentile? That is, what proportion of SAT takers did worse than Edward? So in this case, again, here's the SAT, 15 mean of 1500. He scored 1400, and we want to be worse. Figure out what proportion is worse. So the way you find percentiles is you find the proportion that's worse. So normal CDF, in this case, negative 9999 up until his score, 1400. I'll leave the mean and standard deviation alone. Paste. And I get about 0.369, so that's about 37%. That means Edward scored about the 37th percentile. So lower bound, negative 9999, upper bound, 1400. Normal CDF, negative 9999 to 1400, the mean of 1500, the standard deviation of 300, 0.369. So Edward scored in the 37th percentile. Finally, Stewart earned an SAT score of 1500. So what percent of SAT takers did better than him? So here's his graph. And center is the SAT mean of 1500. He is way over here, and we want to find those who did better. So that upper tail. Lower bound 2100, upper bound, say 9999. Normal CDF. $999. Paste. Enter. And I get about 2.275, so about 2%. So about 2% of SAT takers did better than Stewart.